Hello, everyone. Can you hear me well? Perfect. Thank you. So, hello. Hope you enjoyed your lunch. Hope you're awake because I will have some algorithms, not exercises, nothing. So you can relax. I'll do the talking. I'm Mihaela. I'm a software architect at Systematic. This is a Danish company specialized in building software for what we call critical domains, meaning that we are developing software for domains like the defense, which represents the business unit for which I'm currently working. So we are building software for NATO and its allies, but we also have healthcare, national security risk, and many others. And I'm telling you about the domain so that you can understand some of the restrictions and decisions that we took on the technical side because of the domain. I'm also an assistant professor at the Faculty of Cybernetics. I'm teaching mostly algorithms, so hence my presentation here as well. And today I'm going to share a real application scenario, so how we managed to implement a collaborative text editor from scratch for the defense domain with a lot of restrictions that come from the domain. First of all, it was a challenge solution because we have a mix of different tech stack in our application. On the front-end side, we have Angular, a little bit of old AngularJS, some legacy code that we are trying to get rid of. And on the back-end side, we have Scala and Java. Java for the SDKs, for the integrators, and Scala for everything else. So we had to build some algorithms for this solution, for building this application that will work on the Scala side, on the Angular side as well, and have them work together very, very well. So, first of all, as more and more organizations have migrated all of their workflows and data online, including those from the Defense Department, the expectations was that everyone can work together in real time, especially when it comes to editing documents, because in the military world, everything comes to planning, everything comes to a lot of bureaucracy, a lot of documents, and everyone needs to access them, work together on the same document, have access to the information real time, and so on. As such, we were put in the situation of building something that we called a collaborative text editor solution embedded into our own application. We wanted something like Google Docs or Word or many other software like that will work both with Scala, both with Angular in our application, and we had to build a lot of layers, especially on the security side, on top of the solution. So, let's see what I'm going to present today. First of all, I will have a very brief overview, a bit more than what I've just told you about the defense domain, just so that we can have an overall picture of the restrictions, the constraints that we worked on. Afterwards, I will dive deep into what exactly represents a rich text editor. Also, we are going to look at those algorithms that we have built both on the front-end side and on the back-end side, and see exactly what is a collaborative editing, how we managed to accomplish that solution, and it's bigger on the screen as well, a lot of requirements, additional requirements for which we had to change the solution to adapt based on user needs. And obviously we will have some question and answers at the end. So let's start. And I thought that what better way to explain the context than with some images. And so we are building software for them. Those that are performing their task, if I could use this word, either on land, on air, on sea, or from a centralized command and control server. And you can see some screenshots from our application. That is our software over there in the pictures. And what they all have in common is the fact that before they jump into performing some activity that they need, everything comes to planning, as I stated a few seconds ago. So no matter of the domain where this military personnel have to perform their task, it comes to planning. And for the planning phase, there are quite a lot of users involved. Users that are coming from one organization, and think of organization, when I use this word, as a standalone server where the application is installed, but we can also have joint forces, a lot of allies that can work together on a mission, on a military mission, and they have to bring their servers, their applications at the exact same time and collaborate on the same documents. So it's not important that our rich text document solution to be available on a standalone application, but it has to be available for everyone in a network. So imagine a load balancing solution where everyone can access the same document, edit the same document, have access to information. And I will put some of the requirements on top of what I just explained. These users, these units that are coming from different organizations can have different security clearance levels, meaning that maybe they can access the same document, but maybe they can't access specific portion of the document. So we had to redact those documents, like you see in the movies with that black part in the documents. And there is even more. Most of the time, there is an air-gapped environment, meaning that they have limited connection, limited connectivity to the internet, or not at all. And for example, in a war area, most likely they communicate within some interoperability protocols. So this was an additional requirement. This was the context for which we had to build the application. And now let's see what we managed to accomplish and how. So we received a task, build a collaborative text editor solution. And let's recap a bit. First of all, I said that we have a lot of users from different places, from different ranks, meaning that the security clearance level that I mentioned about. At the same time, it's possible that they are using the same version of our application, but it's possible that they have different versions of our application. Not everyone migrates to the latest all the time. In the military field, they can have a version that we delivered 5 years ago, for example. And there's more. This application can be deployed on different devices. Some of them can use our software from PCs, from laptops. Some others can use the application from phones or tablets. Or it can be a device specific to a military vehicle that is part of that military vehicle. Imagine a tank that has a device that has our software. And there's more. Some of the users have migrated to a cloud solution. So those documents must be available to all the devices, to all the versions, to all the customers. And what is important is that there is a single version of the document, that all of them have access to it, all of them can make changes, and those changes are visible in real time by everyone, with the restrictions that I mentioned about, that we need to redact based on those security clearance level. So, how to do that? And first of all, we said that before we jumped into the implementation phase, because we just had some requirements, some context, some business operational needs based on what I've just presented earlier. But from a technical perspective, we wanted to define the concepts that were involved. We wanted to reduce that large use case that we have received, build a collaborative editor, into smaller pieces of the solution, smaller use cases, and see how we can address each of them. And initially we started by answering a simple question. And that question was, what is exactly a rich text editor? We removed at the beginning the collaborative part, as that involves heavily algorithmic solutions. So let's stick with a rich text editor available for a single user that works fine. So, we can define a rich text editor by an order list of characters. And a character is identified by a specific value, which can be a letter, a number, a space, or some other characters, and an index. And the index represents the numerical position of that character inside the order list of elements. And there's more. With these characters, we should be able to perform two basic operations. And those two basic operations are represented first of all by an insert, and secondly by a delete. And in case you're wondering why I haven't added update operation over here, well, that's because updating a character means that we are deleting the old one and inserting another one. So we can create the update operation by merging those two operations. And there's more, obviously. We wanted to be able to have some advanced operations that should work in such a solution, in a complex rich text editor solution. And these advanced operations are represented by the possibility of applying some styling. Imagine opening a Word, you want to apply bold, italic, and so on. And there's more. We wanted to be able to work with advanced objects because we want to be able to insert tables, to insert images, to insert horizontal lines, to insert lists, headings, and everything else. And from the domain, it comes another requirement. For example, we can have some recordings made by a drone in the field, and we want to be able to have that video uploaded into our software and embedded into the application, either as a simple link or something embedded into application, into the document that can be visible and seen over there. So we had to cover this as well. And not to mention the security clearance aspect that I mentioned about, to be able to restrict the access of users to a certain portion of the document, for which we introduced the concept of classification. And I will have more details about it, especially on the algorithmic side of how we managed to accomplish all of them. So, first of all, we started to look at our stack trace in our application and see if there are some frameworks available on the market that could at least help us build this solution in an efficient and faster way. And on the backend side, we said that everything can work with our Scala Java solution because that's just the backend. It will receive some notification or some notification, persist everything in the database. So the problem was on the front-end side to build that fancy UI options. And there are quite a lot of frameworks available on the market. These are some of them. But we only use these two, Frala and CodeMirror. And they integrated quite well. But why? And this is something generic that was available not only on the front-end side of the application in terms of decision, it's the same on the back-end side. And among the reasons, first of all, we looked at the license. And that's because the collaborative editing part is quite heavy to do. There are companies that spent years developing those algorithmic solutions. We did the same for ours. And they have something like a license-based per installed server, meaning that either us or our customers have to provide a specific number of licenses that they need, 234. Who can provide this sort of number? Well, we couldn't. And that's because, let's assume that in an organization we know exactly how many military personnel we have over there. We can put a backup. But what happens on the field when we have joint forces? And if someone comes from another alley and try to work on a mission with us, they need to connect to the same network. We can't tell them you can't access our document because we don't have enough licenses. So we had to remove all the frameworks that come with this. Afterwards, another part is that while we truly want to share with the community everything that we are doing, we can do that within some certain restrictions. And some of the frameworks are forcing the users of that framework to share the code to the community. And we can't do that. You'll see that I won't have any pieces of code over here, just a theoretical algorithmic solution behind the application. But we can't share the code to the community, and we can't share it not even internally in our company. So people that are not working for the defense business unit don't have access to our code. So this was one of the restrictions as well, and we removed once again some of the frameworks. And there's more. Some of those frameworks didn't have a release for a couple of years, so definitely we don't want something like that in our application. And we rely on a lot of customizations. We wanted a fancy UI, we want a lot of requirements added on the front end or the back end side, so we need to think of the maintenance part, and we sort of removed some of the frameworks from this aspect as well. And lastly, is the compatibility with our front-end framework. Because I mentioned on the back-end, there wasn't any problem. Scala works fine with everything on the front-end side. But on the client side, we are using Angular. And most of them have the restriction of only being compatible with React, for example. And we didn't want to change our entire stack framework on the client side just to be able to use a third-party plugin. And we didn't want to do workarounds to make them work. So we prefer at this point to use those two frameworks that I mentioned about, Frola and CodeMirror, just to have the interface and the ability to apply bold style, different styling format, and so on. So just for the rich text editor side, nothing to do with the collaborative. For the collaborative, we build our own solution, and I'll explain how. But I kept repeating this collaborative editing part several times. What exactly does it mean? Well, we wanted the capability of having multiple users from different locations to be able to edit that document at the same time. Also, we wanted them to be able to have, let's say, a local copy available that they can open in their own browser and start making changes, and these changes to be available for everyone else from the same application, from the same server, and also from all the others that are being connected through some gateways to our own local server. Let's call it like that. So how does a solution to accomplish all of this can look like? Well, as developers, we started to think that it may be something similar to Git. I suppose everyone is familiar to Git? Perfect. I'll skip some of the details then. So, how would that work? And we said something like that. We even did a proof of concept that didn't work. No, didn't work like we wanted to do. Let's assume that we have a file version 1.0 and we have two users. Let's assume that user 1, the fastest one, edits the file at a specific position in that document and ends up with a version 1.1 in their own local server, local version of the application. He's fast, so he merges the changes. Let's assume that he ends up with a version of file 2.0. User 2, a little bit slower, tries to do the same, but because both of them edited the document at the exact same location, user 2 will have some conflicts. So he will need or she will need to fix the conflicts first and afterwards push the changes again and merge. So something like we have with the Git process, if we were to simplify it to these small boxes in the drawing. Well, at this version, at this stage, I think that part of this process is actually great. And it's great just comparing to some other solutions that we have, because initially we thought of something like having the document opened, lock it when someone wants to try to make changes, then unlock it, be available for other users to make changes, and so on. And if we are 100 users connected to the same version of the document, one edits, so all the others 99 will just look. No, that would have been unusable. So the Git started to look a little bit like a solution. But it wasn't enough. And that's because we don't want that users to be prompted all the time to fix conflicts. So the process should happen behind the scene. And at that point, we started to wonder what if our application would simply do its best guess and fix those conflicts automatically for us. Well, that would have been a better solution. And it was a solution. And you may think that what I've just said is a little bit wrong because the application would guess what we want it to do. But if it gets wrong, that one of the users can simply make changes in the document to address whatever he wanted to do over there. And in theory, yes, indeed, it sounds wrong, but in practice, it works fine. It works perfectly, at least from what we needed to do at that point. And that's because the system doesn't need to be right all the time, but it needs to be consistent. So if we have some conflicts, when 10 users try to make some changes, and we'll fix those conflicts that appeared for us based on certain restrictions, certain rules that we have implemented ourselves, if he solves everything all the time, then that's fine, because it will be consistent. And this is the moment when we define the collaborative editing by two keywords. And let me bring them to you. So those two keywords are consistency and responsiveness. So we wanted the text document to be consistent all the time, to fix those conflicts the same time, all the time, for all the scenarios, and to be responsive, meaning that it should keep the user intent. So what he wanted to do, that is what we also need to do behind the scene. And let's see how these two keywords that I have just introduced actually represents. And I will start with the consistency part. And for this, let's take an example. And from here, the algorithmic solution will start. So at the beginning, we have two users, user 1 and user 2, and an empty document. So nothing present in the document at this moment. They both want to make changes at the exact same location. So position 0, 0, let's assume in that document. If user 1 types in the document the word collaborative, the system should make sure that collaborative ends up in the document because this is the user intent. But if user 2 types in the word editor, then his intent is to have editor in the document, so this is what the application should take care, to have editor in the word. But what happens when we try to merge both of the user changes, because both of them are editing the same document? So at this moment, it doesn't matter if we end up with collaborative editing or I wrote editor, sorry, or editor collaborative. What matters is to be consistent. So for this scenario, it should follow the same rules all the time. And for us, it was something like last man wins. So if user 2 is faster, then his changes will go first, and afterwards we will move the positions of those characters based on the text to be able to merge both of them. So at this moment, we wanted to be able to merge everything on the, let's assume, behind the scene application, part of the application, and don't prompt the user to fix these changes, because if user 1 merges and user 2 would have been prompted, okay, someone else introduced collaborative, what do you want to do with your changes? No, that's not a good solution. So let's see how we managed to accomplish this. And I did mention, the conclusion was that we need the document to be consistent and don't have manual conflict resolution. As developers, once again, we started to look at Git. We sort of like how it works, and we didn't want to reinvent the wheel. But we started to look at how Git diff looks like, and you can see here an illustration. It mentions that on line 1, it was changed from collaborative to collaborative editing. It's hard to see the intent of the user, what he wanted to achieve over there. So we needed a better way to think, and we started to think in terms of actions the user has performed. And we started to build objects like this that we were sending between the client and front-end side via the notifications to everyone connected. So we started building up objects like this, where we have the type of the action that is taking place. So remember those actions that I mentioned we should be able to perform with the basic characters. So either an insert or a delete. We wanted to be able to say exactly where in the document something has changed, and that is introduced via the position, so the numerical index of that character or characters inside the order list of characters, and the text or the characters that are being inserted or deleted from the document. And when I apply an operation like this for more users, my expectation is that the document will be consistent all the time. But let's see if this looks okay. Let's return to the previous example. I mentioned user 1 was faster, so we ended up with collaborative. Let's assume that the user now tried to insert editor at position 14. That's the index where that text should go. So the conclusion is that we end up with a collaborative editor over there. The notification will be sent to all the available users, to everyone that is connected, so everyone will see collaborative editor. So far, so good. I suppose this already looks like a solution. But that user 2 doesn't do anything. Just stays there, reads the document, expects something to be changed, and it did. Another text appeared over there. So at this moment, there aren't any conflicts that can appear in the document. But let's take another example. Let's dive deep into the consistency part, and let's see when things started to break down. And I'll simplify a bit, not to have that long collaborative editor example. And let's assume that we have just two letters, A and T, for two users. User 1 tries to insert a C at position 0, meaning that his intent is to end up with a cat. User 2 does something similar, but inserts an R on position 1, meaning that he wants to end up with an art. Let's see what happens on those notifications that are being sent. Well, from user 1 we received at the user 2 local copy of the document a notification mentioning that insert C on position 0. That's okay, we end up with a cart. The notification from user 2 also gets to user 1, and we end up with a crat. And I don't know about you, but I have no idea what that is. So at this moment, the consistency rule is broken. We have two users that are working on the same document, but they see different things. So that's not a collaborative rich text editor. That's something unusable. So something else needs to happen. Let's take another example for a delete operation, because we have two, insert and delete. And let's assume that we have cat for both of them. First user deletes a C, deletes one character from position 0, that's the C, ends up with an A and T. User 2 does the same. His intent is to do the same, get rid of that C. But the notification started to appear. So we will remove more than expected. We will end up with a T. And that's not neither user 1 nor user 2 intent. So at this moment, something else needs to be considered to make sure that our document stays consistent. And these things are represented by two basic mathematical operations. And let's see what are those. First of all, we have commutativity. Second of all, we have idempotency. So two basic rules in maths. By commutativity, it means that the same operation should produce the same result no matter the order. And here we can take a basic sum example. If we have A plus B or B plus A, that should be the same. And secondly, idempotency means that a repeated operation should produce the same result. And here we can take an example multiplying A by 1 several times. We always end up with an A. So these two basic mathematical operations, like the sum and the multiplication that I provided as examples, should apply to what we had built so far in terms of those operations, those notifications that are being sent from one user to another. And one of the solutions that can be used to solve all of this is given by the operational transformation algorithms. And they rely on heavy mathematical rules, and we have plenty of them in our code. And let's see a couple of them. And let's see how the operational transformation actually works and how we managed to solve those two previous problems. Let's retake the examples. I talk faster than I shared the slide. All right, let's take the examples. First of all, we have the commutativity operation, meaning that insert operation. We had A and T, if you remember. User 1 inserts a C, ends up with a cat. User 2 inserts an R on position 1 and gets an art. And this is the moment when things started to break down previously. So, at user 1 we received a notification from user 2. But previously we were receiving it exactly like it was built. Insert R on position 1. That index needs to be changed. So the operational transformation algorithms at this moment represents the fact that we need to change the numerical index of those positions where we are trying to perform operations so that it matches the user's intent. And in this case, it means that we want to insert an R on position 2. And that's because by the insertion of the C, everything shifted with one position. And this is what we follow in our application. What happens from all the other users that are connecting and making changes in the document, and we simply apply some math operations behind the scene to move or translate, to transform, actually this is the word, those numerical indexes where things have to happen. So we get an insert R on position 2, which means a cart. On the other side, for user 2, we get insert C on position 0. Okay, that's easy on the slide as well because we end up with a cart, but in the algorithm we also look at exactly where we try to insert, if something else happened, if we need to shift that C on the left, on the right, and so on. In this example, the document is consistent. So we managed to transform that numerical index where things have to happen and end up with a consistent document. Let's see if everything works fine on the idempotency part, so the delete operation. We had cat. User 1 deletes the first character on position 0, end up with an ANT. User 2 does the same. And when the notification starting to appear at each of the users, then we identify that those already happened. So we don't do anything. We just skip applying the same operation all over the time. And once again, the document is consistent. And yes, once again, it looks like a solution, and it was, only that we had a lot of additional requirements that forced us to even change more or make it more complex in terms of a solution. And let's see how we did that. We had requirements, let's say, both from the operational needs as well, but also from the technical needs. Let's take them one by one. First of all, I did mention that we wanted the ability to work with advanced object. So we wanted to apply list, we wanted to apply headers, we wanted to be able to transform from one to another. For example, imagine inserting a header in the document, then you realize that actually you wanted to have a list. So we had to support all of this. And not to mention just applying some simple style format like bold, like italic, and so on. Let's assume that someone starts playing with those sequence of characters that we have. From position 0 to 10 applies a bold, from position 1 to 9 applies an italic, and so on. We had to merge everything. We had to receive all the notifications, compare all of them, and see how exactly we are going to apply those operational transformation on them, exactly what are the indexes involved, and so on. And let's take an example. Let's assume that once again we have those two users, so a simplified scenario. User 1 has item 1 inserted, user 2 inserts an item 2. From what we saw so far, that's fine. They will both end up with the same text. But user 1 applies the list as a text format, and it uses a bullet list. User 2 does the same, but applies the numbered list. So what's the version that we end up with in the document? Because from what we have implemented so far, or at least what I have described to be implemented so far, this scenario is not covered. Because it can be a combination between them, so a numbered list and a bullet list, or the last man wins. So meaning that we will have what user 2 try to do there, or some other thing. What was important is to be consistent, and I just mentioned what we have ended up with, last man wins. So if user 2 is 1 millisecond faster, we will end up with an order list in that document. But this is a scenario that we had to include. And the solution for this sort of scenarios was to extend our algorithms and add support for what we called complex data structure. So, we based our solution here with the complex data structure on the fact that HTML is a tree-based language. So the DOM itself is a tree structure, and we can simply follow those indexes via the DOM. And we started to add custom data objects like tables, pictures, and so on. For example, when we wanted to change the list from a header, that's also a sort of application or a sort of information that we need to put into those objects that we started to build earlier. And a part of the long list of operations that we had to support those, it was something called the marker operation. So when you want to search something in the document, you want that the return list of results to be highlighted somehow. So we needed to support this as well. And let's see what other requirements we had. And let's assume that we have 100 users connected. One of those users have no idea where to expect changes. At some point you are working, adding some text in one line, and that line got splitted into two, and you have a picture inserted in the middle. You have no idea if other users are viewing the document, if they are working, or at least where they are working in the document. So we had to support the possibility of viewing at least who is connected on our document. And for this, we introduced something called cursor synchronization. And the cursor looks something like you can see here. And example with the table that I mentioned about. If we see that a user is in the middle of the line, at least we can expect that something will change over there. And yes, a table can appear or a picture can appear in the middle of the row that we are also working. And this cursor synchronization was something that we also needed to take care and include it into our operational transformation algorithms. And let's see why. More snippets from our code. Let's get to the example. So we have a cart. At some point in the presentation, we ended up with this word, a cart. And you can see here two colors, a red and a green, representing our two users. First one with red is right before the character A, so on position 1. The second user is with green and is in between A and R with the cursor, so at position 2 at this moment. And this is highlighted in the object. So at this moment, we started to extend the objects that we are sending via the notification mechanism to include this sort of information. And if one of the users inserts an H on position 1, well, we end up with a cart, but we also need to highlight that the users were still in the same location as they used to be before the insertion of the character. So we also have to apply the same translation, the same operational transformation algorithms to the cursors that they have. And you can see here in the example that we had a translation and user 1 with red remains before A. That is where it was, but now it is on position 2. And user with the green, it's now on position 3, meaning that is with the mouse with the cursor between A and R, like it used to be. So we extended our algorithms to include this sort of details. All right. Let's see more into those requirements. A third requirement, was the ability to be able to undo and redo the operation. Let's assume that one of the users simply deletes everything in the document. We want the possibility of restoring that document. And at this moment, we introduce something called a stack manager, an undo redo stack manager that is local for each of the users. So just imagine a simple caching solution where we store all those information, but let's see how we are storing those operations that are being performed. And this is an example for which we need this stack manager. We had some information in the document, we removed everything, we want to restore it. Let's see how it looks from a theoretical point of view at the algorithm. So once again, we have the cart example. The user wants to insert an H on position 1 to get with a cart. We have this operation that we will invert, so we will reverse the operation. An insert means that the opposite, if we want to restore or to redo this operation, means that we have a delete. So at this moment, we have reversed the operation. We end up with delete H on position 1. We push this to our undo redo stack manager. Once the user hits the undo option, then we will once again apply the reverse operation so that he can undo again and so on. So we are reversing all these operations to be able to restore them from the queue. Let's see other requirements. Well, I mentioned at the beginning that most of the users work in an air-gapped environment, and at least at some point they are in an area where they have limited connectivity. Or another scenario, I did mention that some of them are using some devices on their hand, on the field. Let's assume that some of them meshed the device and broke. Well, we need the possibility of at least storing locally those changes to be able to restore them back. So those changes must be saved when the application closes unexpectedly. It's not just a front-end solution, it's a back-end as well. So we need the default part with the server and the database and so on. And let's dig more a bit about this. So we have the client side, we have the server side, changes gets there, and we persist them in a relational database. A simple solution like that. I simplified it to this. And for cases when something goes wrong or the application is simply shut down, then we are able to restore it from there. All right. Let's walk through the stack trace once again, because now we have a more complete solution. So the front-end side uses those two editors that I mentioned, the code mirror for the structure code editing, for the UI's part. We have the Froala that provides even more than code mirror, that allows out-of-the-box possibility of working with tables, for example, and be able to apply all the styling inside those tables, so we didn't have to take care of that part as well. And we also have a local operational transformation engine to apply the user's operations. The backend side is built in Scala and Java. And we also have here the authoritative operational transformation engine, which ensures that even if multiple users send conflicting operations at the same time, they are transformed properly to maintain consistency, like we have seen in the examples. And I think I mentioned at the beginning about the classified documents requirement. I'll show you how it looks. So, for example, here you can see that we have the classification, the security clearance level added at the text document itself, represented in some way in the front-end side. And at each paragraph level, we also have another level of security. And that's because, let's assume that some users can access the entire document, but there can be classified sections inside it. And we had to support this. And this is how it looks, or at least a version of it, if we were to remove some portions of it. And there were more, because we needed to restrict this when users are performing operations. For example, we have a redacted document and the user tries to print it or export it and import it into another server. He can't access those information, so we need to persist those classification details no matter what the users are doing with the document. And I think that will be all. I walk you through most of the requirements. There are plenty more, obviously. I try to sum up the most important ones. I can say that something interesting that probably I didn't dive deep into details is the fact that we had to ensure all of this when we have multiple servers connected through a gateway. And that's when we have quite a large number of notifications, and we had to treat a lot of scenarios to make sure those conflicts are being solved appropriate. And I think there is some time now for some question and answers if you're interested in something more than I have presented. Yes.
Well, I've heard a bit about this guy that said before, Martin Lepman. I don't know if you know him. Mm-hmm. And there is this concept of a CRDT, a completely replicated data type. I think you didn't mention it at all in your talk. Did you develop your own CRDT or use an off-the-shelf CRDT, or?
We developed our own. Okay. So we built everything from scratch in our own local solution. Oh. But it's pretty much the same.
Yeah, the same, right? Yeah. And they develop also an algorithm for this kind of thing, like for marrying changes in rich text is called peritext. Mm-hmm. Because I think that what you do with the operational transformations is more similar to what Google Docs uses. Did you also look into that, the peritext algorithm?
No, we haven't.
Okay, because that's it was published like 4 years ago or something. I don't know when you did this, but
we started a couple of years ago, and each release we are adding even more on top of it. So maybe we did something similar at the same time.
Yeah, that's what I was thinking. That maybe, I don't know, you could look into it, because this is not like something new, so to speak. Like there's also other people working on that, and maybe you can find some synergy and reuse. And another thing I was thinking is I attended earlier this year a talk on offline first software development, and I was thinking that maybe for this military application, when you mentioned people are on the field and they may have no internet connection or something, that they may have to like save everything they do on their local devices and then would automatically synchronize with a server. So is this also this? You have this kind of architecture where the software is written in this offline first architecture, then automatically synchronizes, or do you always need this server for the synchronization?
We always need the server for synchronization.
All right.
Yeah. Thank you.
Any other questions?
Wow.
Just to make sure that I understand, when you were talking about the air-gapped network, it was the whole network with the server and all the users
Yes.
together.
Yes.
So
Yes.
if a user goes offline, it stops working.
Yes. No, the application is working, but he can't see.
But the synchronization
Yes.
and the reconciliation.
Yeah, but once he gets back to the network, then he will receive everything, and we will merge his changes with everyone else.
Thanks.
Yes. Thank you.
Anyone else?
You were talking about the air gap. Can you talk a bit more about the infrastructure? Like, do you have one centralized server in some data center, or you have more smaller servers in each location, close the field, etc.?
We have more servers, and most of them they are interacting for some interoperability operators, like MIP, for example, if you have heard of it. So we have multiple servers connected through gateways. That's our, let's say, main infrastructure part.